So the question is, do you trust Google? Any faith? Do you have any faith in Google? Right? Because here's the thing. Is it possible they could have leaked their quantum computers evidence of the multiverse? Do you believe those theories? Because this isn't the first time we've heard about this. Let's check it out.
Google's latest breakthrough in quantum computing has stirred excitement and debate in both the scientific community and the public sphere. At the center of the discussion is Willow, the company's new quantum chip, which reportedly achieved a computational feat so complex that it would have taken today's most advanced supercomputers an estimated 10 septillion years to solve. Yet, Willow accomplished it in under 5 minutes. This unprecedented result,
again, do you trust it? Do you trust it? Do you have faith in Google and its chip? As you see, I have to pose the question.
Willow accomplished it in under 5 minutes. This unprecedented result has led some scientists, including Hartmut Neven, head of the Google quantum team, to suggest that the implications go far beyond technology. Neven has publicly expressed his belief that Willow's performance supports the idea that quantum computation might actually be occurring across many parallel universes, an idea drawn from the many worlds interpretation of quantum mechanics. This notion, while captivating, is not new. The concept of parallel universes has long fascinated physicists and philosophers alike. In particular, Oxford physicist David Deutsch was one of the first to propose that quantum computing could serve as indirect evidence for the multiverse theory. According to Deutsch, the massive computational power harnessed by quantum computers could be the result of their ability to access computational resources from parallel realities. This idea remained speculative for decades until recent advancements in quantum technology, like Google's Willow, reignited the debate. Quantum computing, unlike classical computing, operates on qubits, which can represent both 1 and 0 simultaneously due to a phenomenon known as superposition. This allows a quantum computer to process a vast number of possibilities all at once. When combined with another quantum principle, entanglement, where particles become interlinked and instantly affect each other regardless of distance, the computational power increases exponentially. This level of parallelism in processing is what fuels theories that quantum computations might occur across multiple versions of reality. Neven's remark that Willow's breakthrough lends credibility to the multiverse theory was met with both intrigue and criticism. Astrophysicist and science writer Ethan Siegel, for example, challenged the connection between quantum computing and parallel universes. He argued that Neven conflated the mathematical structure of quantum mechanics, the Hilbert space, where wave functions reside, with the literal existence of other universes. According to Siegel, while quantum mechanics allows for probabilistic outcomes and complex computations, it does not necessarily imply the physical reality of multiple worlds. Despite this critique, Siegel acknowledged the magnitude of Google's achievement. Willow represents a massive step forward in computational power and could pave the way for revolutionary applications. From developing new medicines to designing highly efficient energy storage systems, quantum computing holds promise for transforming numerous industries. Scientists believe that problems currently deemed unsolvable due to their complexity might be tackled with future quantum processors. Willow is the successor to Sycamore, Google's previous quantum chip that made headlines in 2019 for achieving what the company described as quantum supremacy. Sycamore operated with 53 qubits and later reached 70, while Willow boasts 105 qubits. Each additional qubit dramatically increases computational capacity. This advancement was made possible by refining the architecture of the chip, reducing error rates, and improving qubit coherence times. The fundamental principle that allows quantum computers like Willow to perform so effectively lies in the strange and often non-intuitive behavior of quantum particles. The phrase spooky action at a distance, famously used by Albert Einstein to describe entanglement, becomes a practical reality in these machines. When qubits are entangled, the state of one instantaneously influences the state of another, regardless of distance. This creates a network of interrelated data points that can compute many possibilities simultaneously, unlike classical bits that must process one option at a time. For Nevin and other proponents of the multiverse interpretation, these behaviors hint at deeper underlying realities. If quantum computers derive their power from simultaneously evaluating countless outcomes, where are those outcomes taking place? Deutsch's hypothesis answers this by suggesting that every quantum event branches into a new universe, and a quantum computer is essentially tapping into this infinite computational resource spread across all those realities. From this perspective, each qubit state exists in a different universe, and together they contribute to the computation. This idea may...
I have so many questions about that. What, especially number one at the top of the list, then, okay, what's going on in that universe? Is it like the theories people have of, like, we have our direct clone on that universe and it's doing something similar, but just like they said, with a different outcome? Can we tap into that universe sometimes? You know, I'm going to throw it out there, you know, and it makes me sound crazy, but I think we do that sometimes when we dream, fall asleep and dream. And sometimes we hop to a different timeline, i.e. universe, with our parallel. Like, don't get me started.
Different universe, and together they contribute to the computation. This idea may sound more like science fiction than science fact, but it finds some support among theoretical physicists. Yet, others argue that quantum mechanics works perfectly well without requiring the existence of parallel worlds. According to this viewpoint, quantum behaviors can be described through mathematical probabilities and wave function collapses without invoking other universes. This more conservative interpretation maintains that quantum computers work not because they are borrowing resources from other dimensions, but because of the inherent properties of quantum systems. While the debate over the multiverse continues, the tangible benefits of Willow's performance are undeniable. It represents not only a leap in processing power, but also a beacon of what the future of computing may hold. With the potential to revolutionize material science, cryptography, artificial intelligence, and climate modeling, quantum computing could help humanity solve problems that have remained out of reach for decades. Google emphasizes that these advancements are not just theoretical. The company envisions real-world applications such as accelerating drug discovery by simulating molecular interactions in ways classical computers cannot. Likewise, new battery technologies, essential for sustainable transportation, could be designed more efficiently through quantum simulations. Even energy systems, like fusion reactors, could benefit from the rapid optimization made possible by quantum processing. At the heart of Willow's success is a combination of hardware innovation and algorithmic development. Google's researchers have not only built more powerful quantum chips, but also designed sophisticated algorithms that take full advantage of quantum phenomena. This synergy between theory and engineering allows for progress that was unthinkable just a few years ago. Despite these triumphs, Google remains cautious about overstating the implications. While Nevin's statements about the multiverse have attracted widespread attention, the company continues to stress the importance of peer review, transparency, and scientific rigor. The scientific community will continue to analyze the results, challenge interpretations, and refine the technology. Whether or not quantum computers truly access parallel universes, their utility is already becoming apparent. As the boundaries of computation are pushed further, philosophical questions will continue to accompany scientific ones. What does it mean for reality if quantum computing is supported by a multiverse, and how should humanity adapt if other versions of ourselves are helping us solve complex problems without our conscious awareness?
You hear that? Other versions of ourselves. I think that warrants us looking into it if that's a possibility. Imagine you doing something and something goes wrong and you can tap in to another universe, multiverse, and get the information, or switch out of this one and hop onto that timeline. Not saying we can do that now or that's anywhere near in the future. I'm just saying, imagine the possibilities, bro. Knowing the outcome or having a different outcome. Like, that's huge, bro. Again, we've all been talking about, living longer and supporting longer lives and fountain of youth, and here you have it. Possibly with quantum computing, tapping into this and verifying that it's actually true that there is a multiverse.
These questions may remain unanswered for now, but they reflect a growing intersection between cutting-edge science and age-old human curiosity. In the end, Google's Willow marks a pivotal moment in both quantum computing and the philosophical inquiry surrounding it. Whether it opens the door to parallel universes or simply redefines what machines can do within our own, it stands as a testament to human ingenuity and the never-ending drive to understand the universe and perhaps the multiverses around us. In recent years, scientists have increasingly explored a profound idea that has reshaped how we think about the universe and our place in it. According to some leading theoretical physicists and cosmologists, the universe that humanity inhabits may be nothing more than a thin sliver resting on the edge of a bubble, one that is constantly expanding into a higher dimension. This hypothesis is not science fiction, but rather a real attempt to understand the nature of space, time, and existence itself. At its core, it reflects the limitations of human perception and the scale of a cosmos that may be far more vast and complex than we are equipped to comprehend. The size of the...
Exactly. How many times y'all heard me say we're nothing but a minor blip on the radar, a speck on the radar, bro.
The universe alone presents an almost insurmountable challenge for the human mind. The observable universe stretches over tens of billions of light years in every direction, a scale that defies everyday experience. Even imagining a single light year, the distance light travels in 1 year, about 6 trillion miles, is difficult for most people. Multiply that by billions, and one begins to grasp the impossibility of picturing such distances with clarity. Scientists now believe the universe contains between 200 billion and 2 trillion galaxies. Each of these galaxies, like the Milky Way, may contain hundreds of billions of stars. These numbers are almost incomprehensible, and yet they only refer to the portion of the cosmos that can be observed. Even within the Milky Way, understanding our location and the structure of our galactic neighborhood is no easy task. The solar system resides on the outer edge of one of the spiral arms of the galaxy, orbiting its center in a vast rotating disk of stars, dust, and dark matter. No one can peer directly across the galaxy due to the dense central bulge blocking our view. What complicates matters even further is that the entire galaxy is in motion. Our solar system moves through space at an average speed of 515,000 miles per hour. At this rate, it would still take roughly 230 million years to complete a single orbit around the Milky Way. This fact highlights the enormity of even our local region in the universe. Against this already staggering backdrop, quantum physicists have introduced even more mind-bending ideas. One of the most striking of these is the multiverse theory. This theory suggests that what we perceive as the universe may only be one of countless other universes, each with its own set of physical laws and constants. The notion arose when physicists began to consider how finely tuned the laws of physics are in our own universe.
Imagine we have one universe where we're there existing, but we live underwater like fish. It's not the same. You know what I mean? We're doing the same things, but the one thing that's different is that we're living underwater. Imagine that. That's why I say this always has my mind going.
The specific values of the forces that govern everything, from gravity to electromagnetism, are such that they permit the existence of matter, stars, and life. Yet, the mathematical probability of these conditions arising by chance is vanishingly small. This has led some researchers to ask whether there might be other universes where the constants of nature are different. According to the multiverse hypothesis, all possible variations of physical laws and initial conditions are realized in an infinite number of universes. These ideas draw heavily from quantum mechanics, and particularly from interpretations involving the probabilistic nature of reality. One principle that supports this line of thinking is Heisenberg's uncertainty principle, which states that certain pairs of properties, like position and momentum, cannot both be known with absolute precision. This foundational concept of quantum theory implies a fundamental unpredictability in the behavior of particles, which, when expanded to a cosmic scale, leads to the possibility of branching outcomes, each potentially forming a new universe. Virtual particles, another concept from quantum physics, provide further food for thought. These particles are constantly appearing and disappearing in the quantum vacuum, popping in and out of existence due to the fluctuations in energy at extremely small scales. Some scientists speculate that such processes could be connected to the creation of entire universes. If the fabric of space can generate particles seemingly from nowhere, then on a much grander level, similar fluctuations could spawn new realms with their own realities. Adding to this, newer models in theoretical physics suggest that our entire universe may be a three-dimensional boundary of a higher dimensional space. In this model, the bubble of our universe could be floating on a higher dimensional bulk, expanding into it like a soap bubble stretching outward. Some physicists describe this using string theory and brane cosmology, where multiple universes exist on different membranes, each vibrating or drifting through a higher dimensional space. The implications of this are not just philosophical, but potentially observable. If two of these cosmic membranes were ever to collide, it might result in a phenomenon similar to the Big Bang, restarting the process of universe formation. However, understanding these concepts challenges the limits of human cognition. Scientists themselves often acknowledge that the structure of the universe may be beyond what the human brain is evolved to comprehend. While mathematical models and physics theories can be written down and tested through indirect observations, fully visualizing or internalizing what it means to exist in a multiverse or to be part of a four-dimensional hypersphere remains elusive. This is not a failure of science, but rather a humbling recognition of our place within the cosmos. The very idea that we might live in a universe that is part of a larger, higher dimensional reality is both thrilling and unsettling. It forces a re-evaluation of what it means to be human and what the universe actually is. If every possible universe exists, then perhaps every possible version of ourselves exists as well, somewhere in that cosmic sea of probabilities. This realization, while abstract, has deep implications for identity, destiny, and the nature of existence itself. Ultimately, the journey to understand the universe is one of curiosity and courage. As science pushes into deeper territory, we are repeatedly reminded that our perspective is limited. Our senses evolved for survival on a small blue planet, not for grasping the full geometry of space-time or the quantum foam at the root of all matter. Yet, through imagination, mathematics, and the relentless pursuit of knowledge, humanity continues to reach beyond the veil.